Hello, my name is Krus, and I work as a lead solutions engineer for VMware, and I'm specializing in networking and network security in virtualized environments. Today, we're going to talk about the SASE concept and the initiative that VMware now takes around the concept. And today, together by my side, I have my end-user computing specialist, Christian Nilsson. Christian.
Hi, my name is Christian Nilsson. I work as a solutions engineer and user computing at VMware.
Let's look a little bit about the different components that you have in a SASE solution. So, of course, there has been a lot of changes in modern infrastructure, in modern data centers, and in modern application development and consumption. So the old traditional model where we had control over all the users and the consumptions, and there was clear inside and outside where we can put our firewall in between, and where the applications is very traditional and very sequential. This is no longer the case, of course. So there's a lot of applications that have evolved, and an application contains a lot of different components, and those components are probably distributed in a number of places, and the consumption of these applications are also distributed. The DC itself has evolved, and there's a lot of software-defined components nowadays where security and networking is treated the same way as any other software-defined object. And together we form a logical infrastructure that is not the same as the physical infrastructure, where our customers can run their logical infrastructure even though they do not own the physical infrastructure. And of course, the branch has evolved. We are working from the office, we are working from home, and we are working from airports and from customers and coffee shops, or whatever is your example. And of course, this has been even more clear now the past year, since we've been hit by the COVID, that there's a lot of people that find a lot of quality working from elsewhere than from the office. And of course, when working from home or working from wherever, you demand the same user experience, and you demand the same services and the same level of security, of course, regardless if you are working from an office, from home, or from anywhere else. So from a SASE point of view, and introducing the SASE point of presence, what we are basically doing now is that we are taking a lot of network functions and taking those functions, creating them as software object, combining those with a lot of security, software-defined security, and we make this a distributed infrastructure that our customers can consume. And there's a lot of attention around SASE, and probably this is something that will be a main consumption model for a lot of use cases going forward. And of course, we are not only consuming network and network security from persons consuming something in the network. There will be a lot of use cases going forward where there are different types of functions that are consuming the network and is of need of security functions, network security functions. And of course, it doesn't make sense to install a fully fledged network security infrastructure whenever there is a need for a consumption of networks. So it makes sense to basically have security functions in the cloud rather than at the site where you have your function. Okay. So when zooming in at a SASE point of presence, and of course, VMware will have a lot of point of presence, SASE-PoPs all over the world. But if we zoom in on an individual point of presence, we can see that there are a couple of components, and we are introducing this concept now with a couple of functionalities, but going forward, we will of course introduce more and more functionalities into our SASE-PoPs. But basically what we can say already today is that we can distinguish between a couple of different, how do you say, different components in our SASE point of presence. So the first one is, of course, there has to be a way to coming into your virtual infrastructure. So we say that we have a zero trust network access, the secure access provided by the VMware end user story. Once you are with your traffic, you are inside of your virtual software defined your network as an overlay network on top of existing infrastructure. And typically the infrastructure will be mostly internet, so someone else's infrastructure. But of course, you can combine it with your own infrastructure, such as MPLS, or if you have your own fiber infrastructure. The network will connect you with all your different components that you have in a secure manner. And then you will do a couple of different use cases. We have a couple of different use cases when it comes to exit of the overlay network. So basically, you can look at it like this. If you see on the left side, we can basically have a grouping of different use cases when it comes to stuff consuming the network and the network security. So from the left side, we can see that we have users or components connected somewhere. So they are at home, they are at customers, at airports, or wherever they are. So basically, we have a standalone device connecting to the overlay network. There's a lot of drivers towards home offices. So probably in the future, we will see even more home users where basically the workplace is from home. So they have an home office. And of course, there will be still a lot of regular offices all over the world. All of these different use cases, users and use cases, they connect to in a secure way to our overlay network. And on the right-hand side, we can distinguish a little bit about what stuff you are consuming. So we can say that there are basically three different main consumptions that you are doing on the right-hand side. So you're consuming stuff that you have built or at least hosting yourself. So they are in your own data centers. We will also probably consume a lot of SaaS services. So basically services that are trusted but provided by someone else. And then, of course, there will be a lot of stuff that our users will consume out from the internet, regardless if those are applications or if they are just websites that our users are visiting. We can say that these are untrusted applications, and we should be able to cope with all of these. The SASE points of presence basically will be built in the same locations where VMware already have what we refer to as cloud gateways. Because in our SD-WAN offering, already as of today, we have hundreds and hundreds and hundreds of different cloud gateways where our customers can consume the overlay network and they can exit somewhere in the world depending on where the application wants to go. And this traffic is protected from a security point of view by ciphering, and also it's protected from a quality point of view. Let's go into details later on. So we have basically enabled our gateway components or gateway places in the world to have these full functions, and then we call it a point of presence. So a SASE point of presence, the ambition from VMware, you can see down below, that is to have 80% of the population in the world to have the ability to connect with whatever device they have. They should have the possibility to connect in uplink direction to a SASE-PoP within 10 milliseconds of latency latency. And also the ambition is that we should be able to reach all the major data centers, all the hyperscalers all over the world from a SASE-PoP in outgoing direction within 5 milliseconds latency. That's the ambition. So when zooming in even more into the functionality of the SASE-PoP, let's start with the Zero Trust Network Access, the secure access component provided by end user computing. And here I hand over to Christian Nilsson, who is our expert in those matters. Christian.
Now we're going to take a look at how we can achieve Zero Trust Network Access from an endpoint perspective. To achieve Zero Trust, we would need to validate each and every step within the full process. When it comes to Workspace ONE, we look at the end user, how they authenticate and validate that it's the correct user accessing resources. On the endpoint, we make sure they are configured in the framework we've set up with the company. We distribute application in a secure way to the endpoints with how they should be configured. Once the application is onto the endpoint and the end users are accessing the application, they will start communicate back to either an internal resource or an external resource. But anyway, we need to secure that access to the backend for the communication. With Workspace ONE, we have full visibility of the users, endpoints, and application, and how they communicate onto the network. That gives us the ability to actually correlate this data and have a dynamic security settings in each and every given moment, because that is dynamic and it will be changing. You go from corporate network off the corporate network using different applications at different situations. So we keep on validating that all the time. The endpoints, we use device management to configure the devices. We push profiles with payloads on how they should be configured, what security settings that is to be used, what can be changed, and such. And also with device compliance, we always keep on checking that the device is compliant and within the framework we set it to be. If not, we can do remediation of that device or application. So for instance, if out of compliance, we might be sending just a notification to the end user, but it could also be removing an application, a profile, or network access to certain corporate resources, or even put it onto a quarantine network. But once that is fixed, we can automatically put it back, either resource or application that we had removed for security reasons. So looking at conditional access, in this case, we have a managed device on a known network. We just grant access to the applications. Looking at a managed device, but from an unknown or predefined network, we would prompt for two-factor authentication, so we can validate that it's the correct user trying to access the corporate resources. But as if it's known or unknown network, not under management or out of compliance, in this case jailbroken, we won't give access to any application. If we're looking at the top use case here, it could be either that the Windows device is out of compliance or not under management. So directly at boot up, we will start looking at health attestation and the device posture before granting access to application. Looking at the use case in the bottom here, we have a managed device that is will be validating if it's compliant with AirWatch compliancy. Looking at is secure boot used, do we have encryption enabled, antivirus and firewall is configured the way we should, and is it using the right version of TPM? If passing, we will grant access to our corporate resources. Once using the corporate resources, we would, of course, authenticate it in the pre-configured way we set with our company. Now to the application, we use data loss prevention. So we make sure the application themselves can, how they can communicate with other application, where they can store data or even ingest data into the application, but also leveraged in conditional access. For instance, if not in a certain network, we won't be able to access the application. It might be if we're off the network, we would use a multi-factor authentication, while on the corporate network, we would use a certificate to gain access to the application. What is very important also, keeping the privacy of the user so they feel confident to be having a device that is under management. So we make sure to just look at the corporate application and resources provided to the endpoint, and not looking at the personal application, the data that they do have. And if required to remove corporate resources for some reason, we would only remove the corporate managed resources on the device and leave the personal application and data onto the device. And we're not looking at that at all with Workspace ONE. Now we've been looking at the actual user, how we would secure the device and the application. Now setting up a secure network access. In a traditional environment, we would have our internal resources in the data center secured by a parameter firewall. We would have our endpoint, where we would install the VPN client that would actually tunnel all the traffic into the data center, even those that kind of traffic that we wouldn't want to get into our internal network. With Workspace ONE, we can do it a little bit much more granular and secure. So for each application, we can set up a tunnel. We specify what application that could be communicating within that tunnel, what domain that they can talk to. For instance, in another tunnel, we might be using a specific browser with a specific URL that can communicate within the tunnel. And before connecting this tunnel, we do make sure that the device is within compliance. Otherwise, we won't connect the tunnel. So the traffic that we wouldn't want to go into our corporate network isn't configured to use any tunnel, so it will be immediately stopped and not transferred into our internal network. To make it even more granular, we could use NSX, leverage the device policies that we already create, security policies that we already created, and just reuse those policies with Workspace ONE. But actually what is a little bit new here is the secure access service edge that we provide, that actually is a unified access gateway with a VeloCloud edge. But what is unique here is that we, in a smart and dynamic way, choose where that connections should happen. So for instance, for the internal application, we choose the fastest and most secure way to connect to our internal application through a SASE-PoP that is located on our internal network. But for SaaS applications, we would connect to a PoP that is located closest to the application and has the least unprotected communication to the actual application that they're going to communicate with. If we have unspecified traffic that we're not sure of how to handle, we would send it through a PoP and to our secure web gateway and validate whether it should be forwarded to our service that we want to communicate with. If not allowed or not wanted traffic, we will immediately stop it and not forward it. Now I will hand over to my colleague Anders.
So the very heart of our SASE offering is the software-defined WAN, wide area network, SD-WAN. So what the SD-WAN will do is that it will take all the traffic that comes from the left side of the picture. It comes from individual users. It comes from branch offices, home offices, hyperscalers, or other types of equipment. And those users are pushing traffic into our overlay private network that runs on top of whatever physical infrastructure we have, such as internet or MPLS links or whatever we have. So if you look at the SD-WAN and the different components, you will see that we have three main components in our SD-WAN. So to the left in the picture, we have the orchestrator, and the orchestrator is the GUI where you as an administrator log in to manage and to monitor your infrastructure. It will also act as an API gateway if you want to automate stuff. The orchestrator is typically cloud hosted and it runs as a service for you as an end customer. To the right in the picture, we have what we refer to as an edge. The edge is a piece of software ready to be installed somewhere in your infrastructure, and the edge could be packaged as an OVF, as a VM, so that you can install it in an already prepared environment. You can also package that software in a purpose-built appliance, so you can send that appliance to some office or a home user or whomever, and that person doesn't have to have a technical experience. It's just a matter of powering this device on. So it's a zero-touch, plug-and-play kind of installation. And in the middle of the picture, we have the gateway. The gateway is the infrastructure provided by VMware, and it is installed in hundreds and hundreds of places all throughout the public internet. And the gateways is the location where we will combine with the other functionalities. So the gateway will be a part of the SASE-PoP infrastructure. So what the the SD-WAN brings to the table is the connectivity that connects everything you have that wants to talk with some kind of service somewhere in the world. So of course the SD-WAN brings stuff as ciphering and zero-touch provisioning, zero-touch installation, as we have already mentioned. But the most important thing is what it's doing with the traffic itself, because this is very much more than just ciphering of the traffic. This is not a, how do you say, a managed IPsec service. This is very much more. So if we look at the branch site with the SD-WAN, the green circle in the left part of the picture. So we can see that now. Imagine that this is a site somewhere. Let's say it's an office where we have provided the edge functionality. So it's either a software running or it is a purpose-built box. But what we can notice here is that we have multiple uplinks, and that's one of the use cases of the SD-WAN. So if you have a private MPLS, you can use that if you want to. but we see a lot of companies is skipping the very expensive MPLS link, and they buy not only one but maybe 2 or 3 different plain vanilla public internet connections from, let's say, a couple of different providers. Because one of the things that the SD-WAN can do is bandwidth aggregation. So if you have multiple physical uplinks that you bring to the edge functionality, the edge will combine all these into one very fast link and very high performance kind of link. Everything that runs within the SD-WAN, we do what we refer to as a deep application recognition, DAR. Deep application recognition means that we are looking on who is the source of this particular traffic, who is the destination, what is the destination, what applications are running, what protocols are running, what does the SSL certificate say, and so on and so on. And we can identify a couple of hundred different applications. And depending on what we want to do, we can, on a per application basis, we can treat these applications depending on what we want to achieve. So imagine that we have a highly prioritized real-time service running at this edge location. This application is sending real-time traffic. And what we do with the uplinks, one of the functionalities that we have on the edge is that it's, of course, knows how much bandwidth the individual physical uplinks can bring. But we will also probe these links constantly. So we know exactly what is the latency in every instance of time. And we know also by checking the traffic, we know the number of packets that we lose, and we see the bit errors. So if we want to, we can do what is referred to as a per packet link steering. So if we have a highly prioritized application, we can make sure that that application is using the best suitable link if we have multiple. And if something happens to that link, we can use the other link and then going back, and we can do this not a per session, but a per packet kind of fashion. Of course, we can prioritize if we have a bunch of different applications using the same overlay SD-WAN connection. We can use different kinds of quality of service settings, so you can prioritize your different applications. But we can also do what is referred to as forward error correction, meaning that if we see packet loss or if we see bit errors, the system itself, the SD-WAN itself, can correct those. So removing that burden away from the application to do that end to end. And one of the cool things that we can do is that if we have a highly prioritized real-time service and we suffer from bit errors on the different links, what we may do is that we may send the same information. If we take the individual packet as an example, we can send the same information multiple times on the same link, and possibly combine that with sending the same information over multiple links, just making sure that on the other side we have at least one frame that is combined to be an error-free link if there is no time for doing retransmission, if this is a highly prioritized real-time service.
Now I would like to show you how this looks in real life. And you see me being tunneled into the corporate network, into this test application that we created. Now accessing an SaaS application using Firefox that has been deployed from Workspace ONE. Now also looking at how my breakout, what it looks like using this application. I go to my IP. As you can see with this application, the closest breakout is with Zscaler in Germany. This also works for native applications. In this case, we're going to use Slack. Up in the right-hand corner, you can see that we are using the tunnel network.
Okay, so have a quick look on how the VeloCloud Orchestrator GUI looks like. So this is cloud hosted, as we said. And when you are logging in, you get into the monitor view. And in the demo setup, you can see we have 4 different locations. We have the VMware office in Solna, where we have our data center. We have installed an edge from the marketplace in AWS Frankfurt. We have my home office, and we have an office in Uppsala, which is a little bit north of Stockholm, where we have a couple of employees. We can see that everything is green here, and we can see the number of connections. So for instance, if I click on my home office, we can see that I have plugged in a fiber from one provider, and also I have a 4G connection from one of the mobile operators here in Sweden. We can see the performance of these links, and also we can get, if we want to, the actual numbers of the latency that we have at this very moment. Because as we said, we are doing probing of all the links all the times in both directions. We also get information of what applications that are running in each site. If this is what we want, we can see the sources that is accessing different destinations. If we go to the edges overview, we also get a map where we see that we have one location, as we said, in AWS Frankfurt. If we zoom in a little bit on Stockholm, we can see that we have 3 different locations: Uppsala, Solna data center, and my home office out in the Stockholm archipelago. If you go to network services, we see that we have 2 things of interest. First of all, we have a connection between the edge software that is running in the data center. The edge is announcing all the prefixes that we have in the SD-WAN side, everything that is known within the SD-WAN side, and that is advertised using BGP into the data center, and the data center is doing the same thing back. All the subnets and prefixes that we have in the data center is known to the SD-WAN. We can also see that we are using Zscaler as a third-party security provider. So we said that we had 4 different locations, and a few of those locations have multiple uplinks. This means that every uplink has its own connection to the Zscaler cloud infrastructure. So in this particular case, if we want to, we can push traffic that we don't trust through the Zscaler functionality, and via Zscaler it is exiting out on internet with the security features of Zscaler. The way you configure this, most of the stuff is handled by a profile. So most of the settings that I have on my edges will be provided in the profile that I'm applying. But if I want to, I can go into the individual edge, and I can say, for this particular edge, I'm overriding the settings in the profile with this specific settings. And let's just have a real quick look into the Zscaler admin GUI. This is not our product, but let me just show you that what we have done in our setup is that we have registered as a partner integration the SD-WAN from VeloCloud. And we can see that now we have the possibility to use all the security features provided by Zscaler when we are exiting from our VeloCloud SD-WAN out on internet. So the final piece in this demo is that I'm showing a little bit of functionality that will be in the long run included in the SASE concept, and this is what is referred to as edge network intelligence. So edge network intelligence aims to analyze on the LAN side, not only on the WAN side of the SD-WAN, but also on the LAN side. So in this example, I'm showing you the client that is installed on my Apple, my MacBook, and you can see that this is providing information about how the situation looks like from my end point of view. And this concludes our demo.